Hi, we're going to explain our topic, which is particular antiderivatives. So first, we're going to explain what a general antiderivative is, so you understand the context of the topic. So this is a function, and after you do the antiderivative, you're going to have a c at the end, because we don't know if before you did the antiderivative there was a number there. So we're going to place the c as a constant, just symbolizing that there may or may not have been a number there. And now Hector's going to explain particular antiderivatives after you know what a general antiderivative is.
So now, first of all, to find a particular antiderivative, you need to know what the function means and what the x represents, like the numbers it represents. In this case, the function represents 2 and the x equals 1. So after changing that values over there, you simplify the numbers and isolate the c. After isolating the c, you get a constant, a number, which represents what the c was before the antiderivative. So after doing that, you just plug it in and you get the exact function that was.
So the difference between these is that in the general antiderivative you just have a c, and in the particular one you actually found the value of the c.
Thank you.
In this first example, we're going to solve the following equation. Sine over cosine has a trigonometric identity of tan squared. So we have to evaluate for tan. And then in this equation, now we can find the antiderivative. Which is secant squared. And we follow the process for finding u. And the answer will be 1/2 tangent of 2x plus c. This is our u. And if you find the derivative of 2x, it equals 2.
Now we move on to finding c. In this equation, we will now have f of x will equal to 0, and which this will equal then to 3. So this is all just a case of substitution, in which the 0 will be placed where the x is, while the 3 will be placed where the f of x is. So in the end you get technically 3 equals 1/2 tan 2 times 0 plus c. And what you're trying to do is actually trying to find c. So in this case, this will all equal to 0. So you just quickly know already that the answer is 3. So to finalize all the problem, you need to write f of x equals 1/2 tan 2x plus 3. And that's your final answer.
Okay, so this is example 2, which in f of x the function equals 4 cos 6x tan 6x plus c 6e to the 2x. So you have to integrate that, and an identity of tan is sine over cos, so you cancel that. And then you get sine plus, and in this part you do it like separate, another integral. So you get that u equals 2x and u prime equals 2. So you can simplify 6 over 2 equals 3, and you get the u. So the u initially was 2x, so this is your answer for that part. And in here, the 4 sine 6x dx, the u is 6x, so the u over 6. 4 over 6, negative 4 is over 6 cosine of 6x plus this. And that's the answer without a particular antiderivative.
The example reads that f of 0 equals 50. So what we have is the problem already with the antiderivative over here plus c. We equal this to 50 and x to 0, as we can see here. So negative 4 over 6 cosine of 6 times 0 equals cosine of 0 equals 1, and 3 e to the 0 equals also 1. So we get 50 equals negative 4 over 6 plus 3 plus c. We place it here already. In this part, we isolate the c, so we move the 3 and the negative 2/3 over here, alternating the signs, and we have 143 over 3, which is about 47.66, and that's equal to c. So our particular antiderivative is f of x equals negative 4/6 cosine of 6x plus 3 to the e to the 2x plus 47.66.
We concluded that this core activity helped us reinforce our knowledge on solving integrals and antiderivatives, especially the topic that was assigned to us, particular antiderivatives. These type of projects challenged us to organize our time and availability in order to achieve the desired outcome, which in this case was a video explaining particular antiderivatives and showcasing a few examples on how to solve problems as such. Overall, our experience during this core activity was great. We worked well as a team and everyone contributed equally in this activity.